We analyzed the different parts of the stair, which I said were the run and landing. Now, in order to be able to edit more and also make a geometric change in our design, we need to be familiar with parts of run. Alright, because the run itself has some parts and we want to know them now. Alright, now, the different parts of run. It includes 3 lines. The first line is called boundary, and I want you to leave these icons alone for now. I will tell you about them later. Only understand the subject. Now, these green lines are called boundary. Then we have riser, which is these black lines. And then we have the stair path, which is the blue line in the middle. Each of these, my friends, have 2 points to say. Now, if you have a book, you can find it there. Or if you don't, it's okay. I'll tell you right now. You can take a note and keep it for yourself. Boundary has 2 points. The first point, boundary is always 2 lines that are open and separated from each other. It's never 3 or even 1, always 2. And these 2 will never reach each other either. Alright? Somehow we can say that boundary is where the railings will be placed, but somehow not definitely. The second point, it is not correct to pass on the boundary line. I mean, you never enter the stairs from here, you always come from here, right? And even you never hit the boundary lines, you just go through them. And it actually makes sense because there are railings and, well, you walk between the railings. We will need these points later, so be careful with them, alright? Now, 2 points for risers or the black lines. The first point, the 2 heads of these lines must be connected to the boundaries or even reach them. Even if we continue it, it can reach the boundaries. It's okay not to be connected, but if we can continue it, it will reach the boundaries. Now, the second point, these lines must not cross each other at all. You see, just like the picture, they have to be on their own place, just like you can see, they shouldn't change and cross each other. Now, 2 points for the stair path. The first point, the stair path must be connected to the first and the last riser, and also must cross all the rises. I'll repeat it, it must be connected to the first and the last risers, and must cross all the risers. Alright, just like you can see, but I will explain it to you more later. Number 2, the stair path is designed automatically. You don't need to do anything. But in case it is not drawn correctly, we need to design manually. Alright, we need to design it ourselves. Well, now we know everything about the parts of the run. About landing, let me tell you that it has parts. Well, let's just say part, it has only a boundary. Alright, just a boundary. You see, it's this green line, the boundary. But the points about this boundary is not related to the boundary of the run at all. But if I want to tell you a point, the boundary here is always a closed shape. And it cannot be 2, always 1. Alright, now let's go and see the design of all these. We have stairs here, and I want to start editing it, so I select it first before the cut sign, or double click or edit stairs, and then I select it. Pay attention, When you select your run, you see some arrows. When you select your landing, you will see some arrows. I already told you that until you don't make a main change in your design, run and landing are connected to each other. And if you make a change, they will be balanced automatically. But now that we want to have access to the parts of the run, we need to exit the automatic mode. And then do what? That's right, convert to sketch based. Or let's just say convert it to the manual mode. When you want to have access to the parts and ingredients of run or landing, you need to convert them to the sketch based. And then they won't be automatic anymore. So I click on convert here, and then a message shows up that explains that we are converting the automatic landing or a run to the sketch based. And well, if you activate this, it will not show up anymore. Well, now can you say what happened? Exactly, the arrows disappeared. So when we convert the run or landing to the sketch based so that we can have access to the ingredients or the parts, these arrows disappear, and when this happens, we can find out that it's not automatic anymore. So I selected, and here the edit sketch is activated for us now. For this one, it's inactivated, so I select that one. The edit sketch is activated and I click on it. Now, what can we do? Well, let's start with the simple ones. For example, I can drag this boundary here, and I said that they don't need to reach this. If we continue it and then they can reach it, it's okay. Then finish. Now what happened? The landing balanced itself with the run. Why? Because our landing hasn't been converted to the sketch based yet. It's still automatic, so when it is not converted, it balances itself with the run, just like this. So let's continue. I select it and then click on edit sketch. And now I want to design an arc here. Make this arc. If you delete boundary line, you have to draw the same material instead of it. I mean the boundary, the same material. So click on boundary and then select arc. And after that, design it. This is a graphical problem, don't pay attention to it. And I should be also careful that when I draw this, when the risers continue, they can reach the boundary. And then I click on finish. Now, does the landing still balance itself? Yes, because it's still automatic. So remember, when you delete a line and you want to draw it again, it needs to be the same material. Now I want to delete this riser and have an arc. Just like this. I delete it and then draw it again with the same material. And there won't be any problem. I can do many other things like this. Finish. Or I can even make this riser look like this. And even this one. And finish. Alright. Also remember that our edits don't always remain so nice. Actually, from now we start facing some errors. Now, for example, one of the things that we can do is that we delete this boundary, and instead of it, for example, I want to draw an arc. So I click on the arc from boundary, then I design the arc and click on finish. Pay attention. A message shows up. But what does it say? It says that the stairs run and landing cannot be joined. Now, what times does this happen? When the geometry you have designed for your run does not fit the landing. My friends, listen to this sentence I'm going to say right now very well. Revit shows us the unjoined messages in different forms. For example, during the layers of walls and floors, we saw this message. While attaching, we saw this message and many other places. The only unjoin that you need to pay attention to is the unjoin that appears after designing the geometry of the run. Now, how do I find out this is it? When you click on unjoin, you go to 3D and you see this is upside down. So when you receive this unjoin message, definitely click on unjoin. Then go and check it, and if you see your run is upside down, be sure that you cannot ignore it, and the only solution is undo. Alright. If I click on undo, it will be alright. Now you say, why? How did this happen? Well, because I designed an arc instead of this. And then I clicked on unjoin, and when I went to 3D, I saw that it's upside down. And it's actually so dangerous, so I get disappointed. So what would I do? I delete it first. Then I select the boundary and draw this one instead. I say that I'm sorry, I draw it back again, the same way. But would it be alright? No. There is only one way, and that's to undo. You see, you must click on undo until it gets correct. Now a point. While you're editing your stair, every level, each level, you need to click on that check to make sure things you have done so far have been accepted by Revit or not. Actually, this is very good for you because you can understand where you have made a mistake. If you do it immediately after each other, you can understand that, yeah, it has been a couple of levels back that I have made a mistake. You need to understand where the mistake is. By the way, if you do this, let me do something here. 1, 2, 3. Let me delete this one. 4. Now I'm actually working and I forgot to click on that check. Until now, the things I have done have not given me any warnings, but I must have clicked on that check. Now, I do the dangerous thing. I edit this one here, and then I click on the check. Now, what disaster can you say it is? When I click on unjoin and then I find out that this is upside down, I should undo, shouldn't I? But until where? Until the part that was correct. So all things I have done until now will go away, and it's like I haven't done them because I didn't click on the check. Right? So even if you have made 20 changes in your design and then the error turns up, you will have to do it all again because you have to undo. So every 2 or 3 changes that you make, it's really good to click on that check. Now someone comes and says that I want the exact form of that, sir. So what is the solution? Well, I can teach you a trick so that you can use it in these times. Now, what is it? Well, look and pay attention. Well, when you edit this boundary, Revit only cares about the place of connection only here. So if you want to draw that arc, if you keep a piece of this connection, right? You saw I clicked on that unjoin? I told you that unjoin messages of Revit are not important at all. Alright, so if you keep a piece of that here so that the connection is still there, and then you draw that arc, you can do it. Alright, this is the trick. You keep a piece of it there and then draw the arc. If you do this, you will not face any error. And then you might say, so what about this piece here? Well, it's a trick. It's not a solution. Keep that short as much as you can. And in 3D, there's an extra part like this. You can delete it. Actually, I myself have done this a lot. There's no solution. Well, you just have to do it, and nothing bad happens. And this is the trick. Well, when I edit my stair here, for example, I change the direction of this a little and then trim these two. When I click on finish, what error does it show us? Invalid stair path. That's right. Because this line has not reached that line under it. Alright, I told you it must be connected to the first and the last riser. So I select it and then correct it and finish. Alright, now we nearly checked the errors of stair. Now I want to draw some stairs with mistakes and problems, and it's your duty to find those mistakes and problems and then inform me. And actually in this part I have a lot to explain to you. So let me delete this and draw another one. 212 would be good. Alright, now I want to edit this. Pay attention. So I select this and then I convert it. The message shows up. Then I select it again and then click on edit sketch. Then I change the direction of it, this boundary a little. And from now on, be careful because I'm going to make some mistakes and you need to be able to recognize them. In order not to face an error here, I make this a bit short and then select a boundary and draw it in this way, for example. Now the stairs might look a bit weird, but I just don't care. Then I delete this and draw another risers instead. And I change this one too. And I delete this one too and change it. Just like this. Well, that would be enough. And now I'm going to click on finish. Before you tell me the mistakes of these stairs, I need to explain something to you. Now I click on finish here. Alright, finish. That's it. And then a warning, an error shows up that says invalid sketch. Now pay attention. Guys, the invalid sketch error is related to risers and boundaries. I mean that it's telling us, it's informing us that the boundaries and the risers have issue. It hasn't controlled the stair path yet. As long as there is problem with the boundaries and the risers, it doesn't go to the next level. So let's correct the boundaries and the risers for now. We do this first based on the previous points and then we go for the stair path. So I click on continue and you need to tell me the problems one by one. And you actually need to say it doesn't matter, I cannot hear it. You need to say. That's right. The first thing that seems so wrong is this boundary in the middle. It's conflicting both points that I said about the boundaries. The first point for the boundaries, there must be two lines. There are three now. So we can't have a boundary here. The second point, we cannot pass the boundary. Now if we climb the stairs, we will pass the boundary in the middle. So this is wrong. It must be what? That's right, it must be a riser. So, we analyzed the different parts of the stair, which I said were the run and landing. Now, in order to be able to edit more and also make a geometric change in our design, we need to be familiar with parts of the run. Alright, because the run itself has some parts and we want to know them now. Alright, now, the different parts of run. It includes 3 lines. The first line is called boundary, and I want you to leave these icons alone for now. I will tell you about them later. Only understand the subject. Now, these green lines are called boundary. Then we have riser, which is these black lines. And then we have the stair path, which is the blue line in the middle. Each of these, my friends, have 2 points to say. Now, if you have a book, you can find it there. But if you don't, it's okay. I tell you right now. You can take a note and keep it for yourself. Boundary has 2 points. The first point. Boundary is always 2 lines that are open and separated from each other. It's never 3 or even 1, always 2. And these 2 will never reach each other either. Alright? Somehow we can say that boundary is where the railings will be placed, but somehow not definitely. The second point. It is not correct to pass on the boundary line. I mean, you never enter the stairs from here, you always come from here, right? And even you never hit the boundary lines, you just go through them. And it actually makes sense because there are railings and, well, you walk between the railings. We will need these points later, so be careful with them, alright? Now, 2 points for risers or the black lines. The first point, the 2 heads of these lines must be connected to the boundaries or even reach them. Even if we continue it, it can reach the boundaries. It's okay not to be connected, but if we can continue it, it will reach the boundaries. Now, the second point, these lines must not cross each other at all. You see, just like the picture, they have to be on their own place, just like you can see, they shouldn't change and cross each other. Now, 2 points for the stair path. The first point. The stair path must be connected to the first and the last riser, and also must cross all the rises. I'll repeat it, it must be connected to the first and the last risers, and must cross all the risers. Alright, just like you can see, but I will explain it to you more later. Number 2. The stair path is designed automatically. You don't need to do anything. But in case it is not drawn correctly, we need to design manually. Alright, we need to design it ourselves. Well, now we know everything about the parts of the run. About landing, let me tell you that it has parts. Well, let's just say part, it has only a boundary. Alright, just a boundary. You see, it's this green line, the boundary. But the points about this boundary is not related to the boundary of the run at all. But if I want to tell you a point, the boundary here is always a closed shape. And it cannot be 2, always 1. Alright, now let's go and see the design of all these. We have stairs here, and I want to start editing it, so I select it first. Before the cut sign, or double click or edit stairs, and then I select it. Pay attention, when you select your run, you see some arrows. When you select your landing, you will see some arrows. I already told you that until you don't make a main change in your design, run and landing are connected to each other. And if you make a change, they will be balanced automatically. But now that we want to have access to the parts of the run, we need to exit the automatic mode. And then do what? That's right, convert to sketch based. Or let's just say convert it to the manual mode. When you want to have access to the parts and ingredients of run or landing, you need to convert them to the sketch based. And then they won't be automatic anymore. So I click on convert here, and then a message shows up that explains that we are converting the automatic landing or a run to the sketch based. And well, if you activate this, it will not show up anymore. Well, now can you say what happened? Exactly, the arrows disappeared. So when we convert the run or landing to the sketch based so that we can have access to the ingredients or the parts, these arrows disappear, and when this happens we can find out that it's not automatic anymore. So I selected, and here the edit sketch is activated for us now. For this one it's inactivated, so I select that one. The edit sketch is activated and I click on it. Now what can we do? Well, let's start with the simple ones. For example, I can drag this boundary here, and I said that they don't need to reach this. If we continue it and then they can reach it, it's okay. Then finish. Now what happened? The landing balanced itself with the run. Why? Because our landing hasn't been converted to the sketch based yet. It's still automatic, so when it is not converted, it balances itself with the run, just like this. So let's continue. I select it and then click on edit sketch. And now I want to design an arc here. Make this arc. If you delete your boundary line, you have to draw the same material instead of it. I mean the boundary. The same material. So click on boundary and then select arc. And after that, design it. This is a graphical problem, don't pay attention to it. And I should be also careful that when I draw this, when the risers continue, they can reach the boundary. And then I click on finish. Now, does the landing still balance itself? Yes, because it's still automatic. So remember, when you delete a line and you want to draw it again, it needs to be the same material. Now I want to delete this riser and have an arc. Just like this. I delete it and then draw it again with the same material. And there won't be any problem. I can do many other things like this. Finish. Or I can even make this riser look like this. And even this one. And finish. Alright. Also remember that our edits don't always remain so nice. Actually, from now we start facing some errors. Now, for example, one of the things that we can do is that we delete this boundary, and instead of it, for example, I want to draw an arc. So I click on the arc from boundary, then I design the arc and click on finish. Pay attention. A message shows up. But what does it say? It says that the stairs run and landing cannot be joined. Now, what times does this happen? When the geometry you have designed for your run does not fit the landing. My friends, listen to this sentence I'm going to say right now very well. Revit shows us the unjoined messages in different forms. For example, during the layers of walls and floors, we saw this message. While attaching, we saw this message and many other places. The only unjoin that you need to pay attention to is the unjoin that appears after designing the geometry of the run. Now, how do I find out this is it? When you click on unjoin, you go to 3D and you see this is upside down. So when you receive this unjoin message, definitely click on unjoin. Then go and check it, and if you see your run is upside down, be sure that you cannot ignore it, and the only solution is undo. Alright. If I click on undo, it will be alright. Now you say, why? How did this happen? Well, because I designed an arc instead of this. And then I clicked on unjoin, and when I went to 3D, I saw that it's upside down. And it's actually so dangerous, so I get disappointed. So what would I do? I delete it first. Then I select the boundary and draw this one instead. I say that I'm sorry, I draw it back again, the same way. But would it be alright? No. There is only one way, and that's to undo. You see, you must click on undo until it gets correct. Now a point. While you're editing your stair, every level, each level, you need to click on that check to make sure things you have done so far have been accepted by Revit or not. Actually, this is very good for you because you can understand where you have made a mistake. If you do it immediately after each other, you can understand that, yeah, it has been a couple of levels back that I have made a mistake. You need to understand where the mistake is. By the way, if you do this, let me do something here. 1, 2, 3. Let me delete this one. 4. Now I'm actually working and I forgot to click on that check. Until now, the things I have done have not given me any warnings, but I must have clicked on that check. Now I do the dangerous thing. I edit this one here and then I click on the check. Now, what disaster can you say it is? When I click on unjoin and then I find out that this is upside down, I should undo, shouldn't I? But until where? Until the part that was correct. So all things I have done until now will go away, and it's like I haven't done them because I didn't click on the check. Right? So even if you have made 20 changes in your design and then the error turns up, you will have to do it all again because you have to undo. So every 2 or 3 changes that you make, it's really good to click on that check. Now someone comes and says that I want the exact form of that stair. So what is the solution? Well, I can teach you a trick so that you can use it in these times. Now what is it? Well, look and pay attention. Well, when you edit this boundary, Revit only cares about the place of connection only here. So if you want to draw that arc, if you keep a piece of this connection, right? You saw I clicked on that unjoin? I told you that unjoin messages of Revit are not important at all. Alright, so if you keep a piece of that here so that the connection is still there, and then you draw that arc, you can do it. Alright, this is a trick. You keep a piece of it there and then draw the arc. If you do this, you will not face any error. And then you might say, so what about this piece here? Well, it's a trick. It's not a solution. Keep that short as much as you can. And in 3D, there is an extra part like this. You can delete it. Actually, I myself have done this a lot when there's no solution. Well, you just have to do it and nothing bad happens. And this is the trick. Well, when I edit my stair here, for example, I change the direction of this line a little and then trim these two. When I click on finish, what error does it show us? Invalid stair path. That's right, because this line has not reached that line under it. Alright, I told you it must be connected to the first and the last riser. So I select it and then correct it and finish. Alright, now we nearly checked the errors of stair. Now I want to draw some stairs with mistakes and problems, and it's your duty to find those mistakes and problems and then inform me. And actually in this part I have a lot to explain to you. So let me delete this and draw another one. 212 would be good. Alright, now I want to edit this. Pay attention. So I select this and then I convert it. The message shows up. Then I select it again and then click on edit sketch. Then I change the direction of it, this boundary a little. And from now on, be careful because I'm going to make some mistakes and you need to be able to recognize them. In order not to face an error here, I make this a bit short and then select a boundary and draw it in this way, for example. Now the stairs might look a bit weird, but I just don't care. Then I delete this and draw another risers instead. And I change this one too. And I delete this one too and change it. Just like this. Well, that would be enough. And now I'm going to click on finish. Before you tell me the mistakes of these stairs, I need to explain something to you. Now I click on finish here. Alright, finish. That's it. And then a warning, an error shows up that says invalid sketch. Now pay attention. Guys, the invalid sketch error is related to risers and boundaries. I mean that it's telling us, it's informing us that the boundaries and the risers have issue. It hasn't controlled the stair path yet. As long as there is problem with the boundaries and the risers, it doesn't go to the next level. So let's correct the boundaries and the risers for now. We do this first based on the previous points and then we go for the stair path. So I click on continue and you need to tell me the problems one by one. And you actually need to say it doesn't matter, I cannot hear it. You need to say. That's right. The first thing that seems so wrong is this boundary in the middle. It's conflicting both points that I said about the boundaries. The first point for the boundaries, there must be two lines. There are three now. So we can't have a boundary here. The second point, we cannot pass the boundary. Now if we climb the stairs, we will pass the boundary in the middle. So this is wrong. It must be what? That's right, it must be a riser. Now, is it possible to change this to a riser? No. But there is something you can do, and that's to draw on it. Oh, I'm drawing with boundary. I select the riser first. and draw it. Now, how should I delete the boundary? Filter, you need to select it first. Filter, activate the boundary, and delete it. Alright, so let's click on finish. Oh, invalid sketch. Still wrong. So I check. What else? That's right, you can see it here. If we continue this riser, it will cross the other riser, right? This one. So I delete it and draw a kind of different arc. Now when I continue the other risers, they don't hit this riser. So now let's click on finish. Well, still invalid sketch. What else? That's right, we have a problem here. I said when the riser continues, it must reach the boundaries, but it doesn't. So what should we do? Well, either we can continue this boundary, or we can also draw an arc instead of that riser. Yeah, just like this. We draw an arc. We can also do something else. Let me delete this and show you. I can also trim these too. It's another way. You see, I kind of bring it down, bring the boundary down so that it can reach it, but I want to draw an arc, you know, just. Alright. Now, finish. This time, it really seems to be okay. Well, that's what we're going to discuss. There is a point about the boundaries that we usually don't pay attention to. And that thing usually causes the damage to us and the stair, because the big things that happen to the stair we can see, especially when we are a little experienced, we can notice those big mistakes. But what we usually miss, well, I don't know if any of you have found it, well, you're really smart, but what we usually miss is this. The boundary here goes out a little. This is what we couldn't find. Or even sometimes a little piece of boundary stays out like this and it cannot be seen at all. Well, who can find these things? Well, I teach you the techniques. The techniques for the times that you have a small piece somewhere and you can't see it. Like here or here. Or imagine we have overlap. Like this. Now, how should we find these? Actually, there is a very cool technique that I will show you. Well, the first thing you do is to hold your mouse on one of these boundaries and then tap. Now, because my computer highlight is gone, I have to close it and open it again so that it can work. Let me see if I can make it this way. No, unfortunately, let me just close it and open it again. And after that, we will continue our discussion. That how we should solve these small lines and also the overlaps. Well, the first thing you do is this. You hold your mouse on one part of these boundaries, it becomes highlighted, and then you tap. You see, tap once and click. Sometimes it shows itself. Alright, when you do this, you see some spots and you see, okay, what are these spots? Usually the empty ones are not important, but when I zoom in this one, you see, and then I trim these two. Again, tap and then click. You see here that the color is kind of different. Here's green, the rest of them are blue. I can open a box here and find it, and this tab is really good. So one way is to tap and find some of them, but what else? Well, the small one is still there, right? When I finish, the warning comes. You can also do something else, and that's to count the boundaries that are clear. 1, 2, 3, 4. After that, you open a box and you go to filter. You see that there are 6 boundaries. So 2 more left. After that, you select the boundaries that you can see and delete them. Then open the box again, filter, and those 2 boundaries will show themselves. Now you can find them one by one. Alright. Even if you couldn't find that little one, you can delete the other one and then open a box. Filter, boundary, and then it will show itself. After you found them, you undo because now you know where they are. So you go where they are and delete them. So by using filter, you find out how many they are, and then when you delete them, you find out where they are. Alright, finish. Now, what does it say? Invalid stair path. Well, can you say what it means when we get this message, invalid stair path? That's right, it means that our boundaries and risers are okay now. The only problem now is the stair path, and it's so easy to fix. It's clear, for example, this hasn't reached here. I just drag it or even use the extend and then finish. Remember something, let me tell you before clicking on finish. Now, remember, after solving all the errors and all the mistakes, now, does the geometry that you have designed fit the landing? After all that, you might face that unjoin, that dangerous message now. Well, it might be like that. Technically, your boundaries, your risers, everything is okay, but the form you have created does not fit the landing. And I told you the trick, and it's up to you actually to change the form or do the trick. When you click on finish, if you face that dangerous unjoined message, I mean, if your ramp gets upside down, well, there is no choice. You have to undo and then change the form. But if any other unjoined messages appears, well, you can fix it, let it be. It's alright, it can be fixed. So let's click on finish to see what message we face. And if it's unjoined, don't worry, don't be scared, just click on unjoin. We have to undo only in case it gets upside down. If it doesn't, it can be fixed and solved. And yes, no unjoined messages and everything is alright. So, let's go. Now, another question. Pay attention really well. I want to do another edit. Alright, now. When did this become like this? Don't remember. They cross each other and ruined the form of the stair, I told you they shouldn't cross each other. You see what a disaster it is? We don't always face an error when the risers cross each other. It just makes a mess. Well, now it's alright. Well, next question. Let me click on edit stairs. Pay attention because it's really important. So, at first I click on edit and then delete this. And draw another form. Let me do it with riser in this way. Remember something, when you have several straight lines connected to each other as a riser, we count as 1. Like the boundary, when they're connected to each other, they're 1. So I deleted that and drew another one instead. What else? I select the riser and draw it here. Here. And finish. What error do you think we will face? Well, the riser I drew here might seem so weird to you. And you might say, it's definitely this one. The error will appear because of this. But no, this is completely correct. Because two heads of it are connected to the boundaries and it has not crossed any other risers. So let's click on finish. You see, no error for the boundaries or the risers. So the form is okay. It's only the stair path. We need to continue the stair path so that it reaches the last riser. Then finish, and now we face the unjoined message. Now, can you say what this is? We agreed not to be scared of the unjoined, didn't we? So, click on unjoin. If it gets upside down, well, we have to undo. But if it doesn't, we can fix it. So, I click on unjoin, and then I go to 3D, and I see it's not upside down. So, it can be fixed. Now, can you say where the problem is? Let me go to sketch. Can you tell? Let me show you in 3D. There is a conflict here. Why do I see that when I'm in 3D? Exactly, because while I was adding this extra riser, I did not delete any riser instead. The truth is that we have added a riser to the first ramp. So the problem is that we didn't delete any riser and then we added one. And it shows itself in the 3D. Alright. So adding a riser can also lead to error. The connection with the landing is now gone. But we can fix this. How? How can you fix it? Well, we delete this one instead. And when I click on finish, not only will we face the unjoined message, but also it will be fixed. So it's possible to fix the stair and the risers when we click on unjoin and it doesn't get upside down. It actually happens a lot. You're in the middle of editing and something goes wrong, but you can fix it. One of the common mistakes is that, for example, someone deletes this and then he wants to offset. So he selects the offset and enters, for example, 30 centimeters. And when he offsets, there will be 2 there without he understands. And then when he clicks on finish, this message will show up. So when we go to 3D, we see there's a conflict. And when you go back and, I don't know, count the lines, you see everything is alright. Well, it's a bit difficult to find this, but when you open a box, if you see down there, it shows 2. This one, it shows 1. This one, 2. It's a common error that appears when you have 2 risers on each other. You can also see it in 3D. You see, just like this. So, be careful. It's so common, it happens a lot, that you have 2 risers on each other. Remember that. And that's it. And actually don't care about these a lot. When the form of your stair becomes a bit weird, it's kind of normal, you know? You can later delete this structure yourself and design another one instead. You can use a wall and a lot more. Let me tell you another point, the last point actually. Sometimes you design a landing artificially. For example, I delete this one and this one, and then I select the riser and draw something here. and another one here. It's kind of a landing I created. Let me get these two down a bit. I kind of create a landing. So let me click on finish and that's it. Would you agree if I say that when this structure reaches the place that I created the artificial landing, it breaks? So what is the solution? When you create a wide thread and it becomes a landing, you need to split the boundaries in sketch mode so that the structure and the railings can balance. Let me continue this to understand where I should split from. Now I can split from exactly that line. I can split from before that or even after that. You will have different effects. I do it from the line. So you see the structure now. Let me click on finish and yeah. And the railing also matches itself with this form. All right. Now I want you to do something, and that's to draw 15 kinds of different stairs, but start from the simple ones. For example, at first edit the boundary and the risers a little, then go for those errors that what should we do if we create a weird form? If there's an extra riser, what should we do if the unjoined message comes? And all that. So practice this part very well because this part was really important. Next kind of the stairs is the kind that two or more than two ramps are connected to a single landing. This one has two ramps, but this one, we get to the landing from three ramps and we exit from it from three other ramps. This one, for example, we enter from two ramps and we exit from one ramp. These are usually used in the lobbies more than others. But what is the technique to draw these stairs? Well, it's so simple. In order to draw these kinds of stairs, you need to imagine that you want to climb these stairs. So first you need to draw one path of these stairs. You go there and you imagine that you just want to climb these stairs. So draw this, but you don't need to draw the other ramp because for the second ramp you can just mirror the first ramp. It's actually a better way to do, easier and faster. For example, this one, we choose a path first. For example, here. Then we draw this one and this one. These two will be created by this. And these two will be created by this one. So let's start drawing. I will explain more during that. Now, the first example. I select the stair first. Well, it has three ramps, so 21 risers would be good. Okay. The actual thread depth would be 30 and 1.20. Location line, right. And when I want to draw this, what should I do? That's right, I need to switch my location line to the left. Now I want to make this bigger, so I select it. The location line is on left, so I can easily make this bigger. Actually, let's just do that one riser ahead, right here, right now. For the other side, I just need to mirror it to the other side actually, so I select it, I click on mirror and the copy is already activated, so it's okay. And that's it. Now they need to connect to each other, so I make this happen. And That's it. Could I do this? No, it would be replaced. So the only thing I can do is to drag it. Now, imagine that I only want to select this side and stick it to the other side. That's it. So I select it and then move it. Now, answer this question. Should I stick it to the first line or the second line? Which one? First or second? Exactly. The second one. Why? Because I said that this is a part of the structure and it could not be there. So we must connect it to the second line. But if you unwillingly stick this to the first line, it's wrong. Now I want to tell you how to understand that the connection between the run and the landing is correct. I want to tell you 3 signs. The first sign is about the stair path. So why don't you tell me? What is the difference between the stair path of the first run, which is correct, and the stair path of the second run, which is now incorrect? That's right, the arrow. This one has an arrow, so it means that it's disconnected, but the other one doesn't have any arrows, so it's connected. When you connect it correctly, there won't be any arrows. So, this is the first sign. The second sign. You see this structure next to the landing, right? Can you see it? When you connect your run in the right way, that structure will be removed. Right? You can't see it anymore. So, the second sign is that the structure next to the landing is removed. Number 3, the railings after finishing. If it's wrong and you click on finish, you can find this out really easily in the 3D, just like this. The railings block this path, so it's wrong. But if they're connected, everything is alright. Now actually the only thing left to fix is this stair path, which is easy. You should just select the landing and then you have to convert it to sketch and then select the stair path and connect it to that side and finish. That's it. Let's go and see the railings too. You see, everything is okay. Now let's go for the next example. I already said that it's not different which one to draw. The desired number would be 24. The first step. The first thing I should do is to fix this landing here and change it. Let me tell you a point. It's really good to know. This landing here now is automatic, so we can't change the form. And I told you that as long as it's automatic, when you change the run, this one also balances. Alright? And when you convert this to the sketch mode, and then you change the run, like this, it's not like before anymore, So, when it's not automatic, the landing does not change with the run. But when it's automatic, it does. And now when I convert this one to the sketch 2, and I change it, it doesn't balance. Oh, that's a bit high. You see that? It doesn't change anymore. Anyway, now, if you want to draw that second example, first of all, we need to convert it to the sketch. But remember not to edit this. before drawing that new form of that second example. So first of all, I click on the boundary and then draw that second example first. Now a question. How can I have a hexagonal that one of its faces is 1.5 centimeters? If you think a little, you know that there was a solution for it in AutoCAD, and you can do the same here. First of all, you need to select this and then click on scale, and this must be scale reference. In AutoCAD, we had to click on R after this scale to go to that reference mode, but here it's automatic. So let's do it. And that's it. After this was finished, alright, you can delete that one and then click on finish. Then the unjoined message appears, which is natural because we moved the landing. But based on what we learned, we should not fear this unjoin. So click on it, but check it in 3D immediately to see if it's upside down. But it's not, so it can be fixed. So now we need to connect these runs to it. So I select this and then copy it, and then I connect it from here. The first or the second line? That's right, the second line. Now, something funny happened here, and that's I can't put it on the first line. I can't even put it on the midpoint of the second line exactly, because this line is nearly in the direction of the other line. So other snaps are not working now. Anytime in Revit that the snap you want is not given to you, you just need to tap. It kind of exits this locked mode. You see, now you want the midpoint, but it doesn't show it to you. If you tap, it will get free. And that's it. Now I want to place another one here. I can move and then rotate it. I can also align it. I click on align. Then I select it and then move it to the right place, right here. The other side is so simple, I just mirror. Right now, a lot of people make a very big mistake. They actually say, why do we bother? We got 3 runs here, we can easily mirror these 3. Which is definitely wrong, because now they're at the bottom. It's the other one which is at the top. And you can't mirror these, because if you do this, it will be more like a platform rather than stair. So we must use this one. Alright? Now, another common mistake that many people make, and that's, let me undo first. Well, a lot of people make a mistake, and that's instead of editing sketch first, at first they delete this. And then they go to this option, which we didn't talk about too much. We have an option beneath the run, which is called landing. So they click on this landing, and then there is a pencil there, a sketch. So they click on it and design a new landing, just like this. I don't say it's a wrong way, it's not a good way, you know, because we don't need to do this, just like this. Now, what did go wrong here? That's right, the landing is not in the right height. In the last method, we edited the same landing because it was in the right height. But this one is not, so we need to fix the height first. Let me put this here so that you can see it. So you can select this, and here it tells you where the base is and where the top is. So what you need to do now is to copy this top. But you might say, why copy? Well, it's 2000, we can write it. Well, I should tell you that it's not always such round number, so it's better to copy it and then select it, and that's it. Now they have a connection, but before that you need to check it. I told you some methods. You check it to make sure that there is connection. And now we are sure that everything is okay. Also remember that while you're drawing your stairs must never have the base offset. Well, of course, the stairs of the first ramp. The second ramp starts from a different height. But generally, the stairs must not have a base offset. So, if we draw the landing separated, which I said is useless, we need to adjust the height again. But if suddenly while working you find out that it was a mistake, you can click on this landing and then use this pick two runs option. If two runs have the right heights, they can connect to each other again. Alright, like this. Like this. Now if you see the top height of this one is 2000 and the base height of the other one is also 2000. So by using this landing, they connect to each other again. Sometimes you might delete a landing unwillingly, so you can use this option. Alright, now I want you to draw these two kinds of stairs so that we can go to next level. Tell you a method so that you can add number of the stairs in a floor. So at first let's prepare a scene. So first of all, let's go to the view, and for example, now we want 10 or 12 levels or floors. Now, if you agree, let's learn the array right here as lines. So I go to modify and then select this and then array. But this time I use linear array. Right now we know the distance from each of these levels to the next level or to the last level. Can you say which one? To the next or to the last? That's right, to the next level, which is now 3.6D, so I changed this to second. Then I click on somewhere and type the distance, or we can do it by the mouse and, just like this. Now I type it. Then I type the number, which is, for example, 10. And I also said I can change the number anytime I want. When you move your mouse on it, the number will be highlighted and then you can change it. Remember, when you increase the number of an object by this array, it becomes like group. We can open a box and then select them and then click on ungroup from here. But if you select them all, you cannot find ungroup because the first one is not in group. When you click on filter and inactivate this and then ungroup, you definitely know why these levels have not yet been added to the list of the project browser, because they have been copied. Array is a kind of copy. But how can we add them? View, plan view, floor plan, and that's it. And then we open a box and they are added. Then I go to level 1. Let me delete these. Then I draw a floor. Finish. Now, how can I increase the number of these floors? Oh, it has offset 2. Let me change it to 0. Now, how can I increase? You already know. That's right, I click on copy, not this copy, this one. Then align to selected levels. Then I select all of them and paste. Now, let's go to level 1 to draw stairs. And I don't want to care about the kind. We are now discussing increasing the number of the stairs. So I click on stair and then I draw a simple one here and here. Finish. Now I want to have the same staircase in every floor. Well, check this out. This thing that we are going to do now makes sense only the times that our floors have the same height. And definitely if each level has a different height, you just have to draw the staircases one by one for each floor. So now we want to discuss the ways that we can increase the number of the staircases in the floors while they have the same height. The first way, select the stair, click on copy and paste it, for example, until 9. This is actually not a very bad way and it's somehow common too, and you can use it. But let me tell you a problem that might happen to you while using this method. If we decide that these stairs need to be edited, we need to delete them all except the first one and then do the editing on the first one and again increase it. But the right way, which also belongs to Revit, is called multi-story stairs. And also remember that this option is only in the 2018 and 2019 version. In the oldest versions, like 2017, 2016, the model is different. This one is specific for 2018 and 19. Alright, I select it first. After selecting the stair, you need to click on the select levels. When you click on it, two icons will appear. Connect levels, disconnect levels. And you can click on connect levels and then select your levels. Definitely we didn't have the levels in the 3D in 2018 version. And you cannot do this in the 3D. When you click on connect levels, it makes you go to view or the section. But in 2019, we can pick the levels from 3D too. Anyway, my advice is to do this in section or view. So I cancel it and do it one more time. Select the stair, click on select levels. Two icons will appear, connect levels and disconnect levels. You click on connect levels and then all the levels that these stairs are about to reach will be selected. So click on connect levels and then open a box and finish. And that's it. You see we have until the top. Now I get disappointed and I say I don't want to have any in the last two floors. So select it and as you can see all of them will be selected. And then click on connect, disconnect levels. One more time. When you hold your mouse on one of the stairs, right, all of the stairs will be highlighted. So select it and then we can see this connect, disconnect levels. Again, I tell you that it's better to do this in the view. So I click on connect, disconnect and then I go to view. We can do this in 3D, but it's better in the view. Now, this time I want to click on disconnect and say I don't want these two at the top. And then finish. And now what happens? Those two will be deleted. Therefore, when you make a multiple number of staircases by using this multi-story stairs, when you want to select it, actually all of the staircases will be selected so that you can increase or decrease the number of the levels by using connect or disconnect. Now a question, what if you want to edit these stairs? Maybe increase the width or even increase or decrease the number of the stairs. If you want to select it, all of the staircases will be selected and we can change only the levels. Well, I tell you how. In order to edit one staircase, you need to move your mouse on one of the staircases, tap once and then click. After that, the connect disconnect will not appear anymore, but instead the edit stairs will appear. The good thing about this is that when you click on edit stairs, Every other staircases will be put aside and you can do your editing on that single staircase, for example this way. And when you click on finish, everything we have changed about that staircase, all the changes will be transferred to the rest of the staircases too. Actually, this was the weakness of adding by line to selected levels, but here we don't have that problem anymore. When you edit one, all of them will be edited. So the point was that when you click on one staircase, all of them will be selected and then you can change the levels. But if you tap once and then click on it, the stair itself will be selected and then you can edit it. Now, let me tell you a few points. But first, let's go to the view. And let me give you a few questions. If I select the stairs and then click on connect, disconnect, and then disconnect a level in the middle, what do you think will happen to this staircase? Well, if I finish it, the two staircases will be one, and they will become a very big staircase. And I don't think it's very useful because this staircase does not match our design. It's just something that Revit wanted to create, that's all. Next question, if I change the height of a level, for example, this is now 10.18, so let me make it 11.50. Well, definitely it will update the stairs, but I don't think this update is that good because the stairs are being updated without we know what change is being made. Is it change in the height or the number of the stairs? We don't know that. So this one is not much useful either. But it's interesting that while you're doing this and then you tap on one of the staircases, those two will not be selected. But why? Because those two don't have the same height anymore. And definitely they can't work with the rest of the staircases anymore. Even if I click on the edit, you see we can't change them. Only the ones similar to each other. You can also stop some of the staircases that are similar from being edited if you want. For example, I tap on this and select it, and then I want to just unpin this staircase. And if I do that, it won't work with the rest of the staircases anymore. So, if I tap on the first staircase, you see that staircase will not be edited with these staircases. So, if you have a change of height in any staircases or unpin any of them, they will not be edited with other staircases. These are the points that are necessary to know if you want to increase the number of stairs. So I undo and we go for the last subject. Now, the last topic is that we definitely need to empty our floors. They can't be like this, they must be empty. Well, one way is to select the floor and then click on edit boundary and then empty the place. For example, now we are in level 5. And then we, for example, open a box and then design a hole. Now, do you think this is a good way? No, because we could just design this one and we just need to do it one by one. But there is a so much better way, which is called shaft opening. Well, in the architecture headline, we have a part called opening, and one of the options there is called shaft opening. You can use this shaft opening if you want to design a hole from down to top with the same form. Just like you can see in the picture, shaft is a vertical volume that creates a hole in each floor on its way. It has nothing to do with the rest of the objects, only the floors. Of course, it creates a hole in ceiling too, but it's not our topic now. We will discuss it later. So let's go and see. For example, our hole starts from level 2. I click on shaft and then design the hole, which is completely up to you. Some people actually don't empty this part. Finish. Let's go to 3D. If you move your mouse around, you can find the shaft. So select it, and then just like the walls, you choose a height for it. The base is from level 2 and the offset would be the same. Now, top constraint, which is unconnected, by change it to level 8. Alright, until we have the stairs. Now, if I change that offset to 0, you see it will not make the hole in this floor. So just keep that 50 or 20 centimeters offset. So that's what shaft does. Creates a hole in all the floors in the same way. And definitely if you have a different staircase in the middle, well, let me select this, tab, unpin and edit only this one. For example, level 4. Well, now shaft cannot work anymore. You see, it means that your shaft can work only until, I think it's level 4, yes. You need to create a hole here manually and again another shaft. You need to edit this. Let me do it, We will fix here later. We need to create the hole here manually and again use the shaft, or we can also copy this shaft. It's in level 6. Paste to level 6. It's not possible to go until the top. There's another thing that I need to tell you, and you need to pay attention to it a lot, right? So, I pick the wall, and imagine I want to draw a wall in this corner, for example here, and then I want to draw some stairs. So, I copy this up to level 2, and then paste it up to level 8. And now I have nothing to do with the connections and attach and join. Then I go to level 1 and draw a staircase. Pay attention. For example here, based on this wall. Let me bring this down a bit. That's it. Now I want to have more of this, so I click on select levels and I go to 3D. Let's just use the 2019 options. Now I want to use shaft, and the point I want to tell you now is this. A lot of people believe that they need to just pick the shaft and do this. Now, can you say what is wrong with what I am doing right now? Finish. Then I select the shaft and up to level 10. Now, the problem to this method is that, let me isolate it so that you can see better. Now, what is this here? Do we have concrete there? No, we have beam there. So the floor must not reach there. So remember that anytime you have a stair or a void or anything in the corner, you need to drag your shaft until the end of that floor. You need to pay attention to this a lot, right? You see, now it's right. We will discuss it later, but know this point for now. The next point is the professional use of shaft for example, duct or void. Now, for example, you want to have a big void here. You can just click on shaft and say that this is a void. We usually design a cross on the voids or even on the ducts. Let me go to view. Here we design a cross to show this is a void or a duct or a place for stairs. You can go to annotate and then click on detail line and draw that line. But while you're using shaft, you can select the shaft and then click on edit sketch and then draw the line inside it by using symbolic line. You can draw the cross, or this one, if you have seen, they draw this in the duct. Now you have this in all the levels, and this is the advantage. Everywhere that we have shaft, you can see this symbolic line. Select it first and then edit it. Now here I have two lines on each other, so I select them and then separate them by filter. Or we can draw this normal cross. Oh, I picked the boundary line. Let me pick symbolic. You can draw the cross, and the good thing is that it will be in every level. Even if you select your shaft and move it, still it will be moved in all the levels. This is actually the advantage of shaft. For example, this stair, let me go to the site and I select this, all of it, and then copy and put it here and also rotate it a bit. Now, what will happen? The stairs have been copied and the shaft has been copied with it. So, shaft is a very interesting tool because when the object moves, the whole of it will also move with it. For example, if you want to move a duct, all the holes of it will be moved with it. Now, you need to increase the number of one of the stairs that you have already drawn, or you can draw a new one, and then practice all these methods, all these points that I told you. You can copy and paste in the floors. Then you can use connect, disconnect levels, create a shaft and the sign on the shaft and everything. Just practice everything. Tell us the different structures of the stair. If you remember, we analyzed the forms of all the stairs, and right now you must be able to design all those kinds. But if you see a staircase somewhere that you think you can't design, just try to contact with me so that we can work it out together. Either I will send you a video or a text or something actually. Now we want to analyze the stairs technically. So if we want to divide the structures of the stairs, we can have three groups. The first one is assembled stair that of course you can understand from the meaning, but what are some examples? For example, wooden stairs, metal stairs, the ones that are made of glass. We can say, for example, the materials that are light, or we can generally say that the stairs that don't have the concrete structure beneath them. These are called assembled stairs, and all these stairs we've been drawing until now have been assembled stairs. Alright, as you can see, just like this. Alright, can you see beneath the stairs? No concrete. Just one structure by its side. which can be wooden or even made of glass or anything. The second one is cast in place. These are the stairs that have concrete. And it's obvious from the meaning too. These are the most common stairs in everyone's project. Am I right? A concrete structure beneath them, and just like the picture we can see. And I will teach you how to convert these, the stairs we have right now. I will teach you how to convert these to the mode that has the concrete beneath it. The third one is a precast stair. You know what they are? They are made with blocks. I will talk about these precast stairs in the advanced course. I think it's better because they're not used that much. But I will say everything about them in the advanced course. So we have assembled stairs and the cast in place stairs. Now we want to analyze the technical options of each of these stairs and get to know what technical settings the assembled stairs have. So let's check this one. We go to edit type first and then analyze all its items. In order to analyze these items in the best possible way, I cut this for you and present a section. Alright, just like this one. So let's go to the section. And this box you see is half. We need to talk about it, is crop. But so that it doesn't stop you from working, you need to click on this don't crop view and then the view opens and then click on the lamp to remove the box. We will discuss it later. For now, our focus is only on stair. Well, I zoom in a little. It has many items that are common with the cast in place stair. Let's check this one out. I select it and then I enter the edit type. You need to pay attention here, alright? These items are related to form and geometry and we've talked about it before. So, let's go down. Well, what did I say the stair is made of? That's right, it's made of run and landing. I said that these are the main parts of the stair. So now we want to analyze the run and the landing. Alright, these parts, okay? These. So in order to enter the settings of this run, click on it once and then you can see 3 dots by its side and then you can click on that. But if you have some specific settings, do not forget about the duplicate. I've always said, remember that duplicate keeps our settings and makes those settings not to get mixed up with other objects. Maybe these settings are only for a specific object, for example, a specific stair. So do not forget about the duplicate. So let's start analyzing the items from the top. One of them, as you can see, is a thread material. It's clear from the name. You can manage the thread material. And definitely you remember thread and riser. Thread was the surface of the stair and riser was the horizontal one. Alright. So you can manage the material of the stone of the thread and riser. As much as you know, you learned it in the walls. So let's go to the thread. This part asks you whether you want to have thread or not. And I don't think it's logical not to have thread. It will be mostly like a trap rather than stair. You will fall. If I remove the thread, it will be like this. It will no longer be a stair. But you might become creative and find a use for this mode. I mean, an object to be like this. Actually, I'm not that creative. There's nothing in my mind about this. So, thread seems to be necessary here. Next one is tread thickness, you know. For example, now it's 5 centimeters, it can be 6 centimeters. Let me make it more so that you can see it. It moves like this. You see, when it decreases, it goes up. Now, the ones that have profile, like tread profile and nosing profile, I haven't taught yet. It's actually related to designing the stone of the tread and its nosing. And I will teach them to you later. But what about this one? This nosing length. Nosing is the edge of the stair tread. And now we can see its length, which is 2.5, and I want to change it to 5, but it doesn't make sense. You see, that's how it will look like. But I should tell you that this doesn't design the nosing as you think it does. You always think that it's an edge that has come out. You might wonder why it is bending. Well, this is one style of a nosing, which can be changed too. So, as the nosing length, we entered 5 centimeters, but it didn't become the one what we thought it would become. So, let's go to next one, the riser. We can not to have the riser, and actually, it's not that illogical not to have the riser. It can be even funny, you know. We have these kinds of staircases, the ones that are made of glass, the wooden ones. Most of them don't have the riser. So it makes sense not to have the riser. We will check it out in the 3D too. So I put the riser back, and this one is what controls the riser's nosing. Actually, this option, which is called slanted, if it's activated, it will make your riser slanted, just like you can see. But how much? As much as you have the nosing. It means that if my nosing is 0, nothing will be slanted. So it depends on the nosing length. But you might say that I don't want it to be slanted, I want it to be straight, so just inactivate it. And when you inactivate this slanted, the nosing will be exactly what you expected. It comes out. Alright? Now, what else do we have? We saw slanted, it was an important item. Riser thickness, you know, for example, 3 centimeters. Riser profile, I said we will talk about it. And then we have a riser to tread connection. In 2018 Revit, it has an advantage that has very nice previews. You can see it has 3 forms. What are they? Extend riser behind tread, extend tread on the riser, or just join all the risers and tread. Now, what does it look like in our own stair? Extend riser behind tread. Just like you can see, riser is behind tread, but it's usually not like this. It's usually like extend tread on the riser. You see, just like this. It's mostly like this because at first we have the tread, then the riser. The next form is for the stairs that, for example, is just one metal sheet or plastic, or I don't know, some things like this. We use join all risers and treads. You see, it's like this. Especially for the times that we don't have the nosing length, it will be so much more logical. You see? Alright, and I will actually tell you how to make this part fillet later. I'm sure actually this is what you're thinking about, but don't worry, we will discuss it later. So, this was everything about the run. Now it's time to go for the next one, which is landing. That's right, landing. In landing, we don't have that special options, but for example, we have this landing type. I open it, but we see that it has nothing. Why? Because here it says same as run. We usually have this situation that the run will not be that different from the landing. So we have an option that is called same as run, which means everything run was, this one is too. But you might say that no, my landing is different. Then I tell you, okay, so inactivate it. When you inactivate it, you see all the options appear. Tread and, I don't know, tread thickness, the length of nosing and everything. And if again you want it to become like the run, you can activate that option. The third part of our stair is called support. What is support? The structures by the sides of the stair. We have two supports, right support and left support. In the right support, okay, check this out. It has very good options, as you can see. First one is none, no support at all. The staircases that are consoled on one side. Next one is closed, what we had. And next one, which is very nice, is called open. You see, the part that is above the stair will be deleted. So we had open, close, and none. And I keep it open. It's better. This is the type of support, actually the design of support. This support here, well, look at the explanation. Let me rotate it a bit to see it from this side. You can select it first and then a structural depth on run or on landing. The structural depth on run, the structural depth on landing. All right, we can have different structural depth on run and in landing. Now it's 15, let me change it to 30. You see that its form changed to the same thing on landing. And next one is the total depth, the important connection between these two. Let me change this to 60. Or change the total depth to 60. Now pay attention to the form of it. You see that? Again, the same form. So, based on this, we can understand that when the structural depth on run increases, the total depth must also increase, and it must increase as much as the structural depth on run increased. Alright, so the total depth must also increase. Otherwise, it will be like this. Let me show you. You see, it will have distance from the stair. Well, now let's go and see what these numbers exactly are. For example, we can go and see it from the east view, just like you can see. Now, check this out. That was my clicking mistake. Now, can you see this 50 centimeters? What was 50 centimeters? That's right, the structural depth on run. So, the structural depth on run is the distance from that corner to this line. And when you increase this distance, for example, you go to this part and change it to 70 centimeters or even 60 centimeters. You see how it looks like now? We changed it to 60. Now check this out. What was total? Total was from this part to this part. And it's 70. When from this part to this part is 60, what is the minimum number it must have to reach this part? About 75. So total is from this part to this part, and total depth is from this part to this part. So total must definitely be larger so that it can reach this part. And you don't need to go to the view and measure this distance and you say, yeah, now it's 74 and blah blah blah. You don't need to do that. You should only enter a very large number for your total depth, and this will not affect your design. Do you know where it will be effective? Where it will change something? The time that you change the mode open to closed. You see, when you move to closed mode, whatever the total depth increases, it gets higher. But when it's open, the Revit does not allow it to get high. All the extra parts will be removed automatically. Well, let's have a review together. Alright, I explained too much, let's have a review. When your support is open, you can control the height of your support, alright? Or we can say that you can control your structural depth on run. For example, 80 centimeters. To not have distance in here, your total depth must be about like 20-30 centimeters more than this number. For example, now if it is 85, it will be like this. Alright? Now, the times that our mode is closed, the structural depth on run would control the distance between the support and the thread. Alright, for example, if I write 80 centimeters, it just comes down. And total would control its height. The more this number becomes, the higher it will be. It's not open anymore to keep it there. I actually told you everything about the support, and if you don't want it, you can just change it to none. And we have the same thing for the left side too. Now, let's change the right and the left support both to open. And now, let's add the middle support. Okay? Now, listen to me. If you activate the middle support, it will add another support for you in the middle of the staircase. And you can also control the number of it. You see, the middle support number. For example, 3. And everything we had for the left and the right support, we have for the middle support too. I just did not talk about width in the previous ones, but it's actually clear it's about the thickness of the supports. For example, if I change this to 8 centimeters, you see, this is how it looks like. You see how various the stairs of Revit are? There are many kinds of stairs here. You can design anything you want. That was all about the technical points of the assembled stairs. Now let's go for the cast in place stairs. And I should say that they're not that much different. Just a couple of small things that I need to say. But now we must learn how to change the assembled stairs into the cast in place stairs. Because when it was default, all the stairs were assembled. So at first we need to learn how to change the assembled stairs into the cast in place stairs, and then I will tell you its technical points. And actually the title of my speaking right now is how to change the assembled stairs into the cast in place stairs, or how to change the assembled stairs into the stairs that have a structure beneath them, just like I told you. So, the first step, select the staircase, go to the properties, and then beneath the cast in place stair, you can see the monolithic stair. Select it. Actually, the monolithic stair is a kind of the cast in place stair. And by monolithic, he means the structure beneath the stair. That's monolithic. So, first select the stair, and then go to properties, cast in place, monolithic stair. Alright? Now, next step, checking the number of stairs and the type properties. Last session we talked about the settings of type properties in the assembled stairs. The minimum of, for example, tread depth, right? You need to control those things and also check the number of the stairs. You see how much I insist on it? Now for this one, this staircase, when it was designed, it had 20 stairs and it was correct. But now the desired number of the risers or the stairs is 23. So the result is that the stair that was correct has not reached the level. Because usually when the type changes from, for example, assembled to monolithic, the desired number of the risers, not the risers we designed, no, the desired number of the risers might change. So you need to change it to what you wanted, just like this. And we will talk about this space here, don't worry. And then we go for edit type and correct everything, edit them. So, select the stair, use the properties to go to the cast in place stair and then the monolithic stair. Check the desired number and then control everything in the edit type. This was the first step. The second step is about the technical settings. Let's have a section of it, and because it's repeated, you know it all. Alright, let's start. This is that crop, if you remember. I select the stair and then I go to the edit type. Naturally, we don't have support. It's actually not logical for the cast in place stair to have support because we have the structure beneath them, but you are allowed to have a support for it. I just don't tell you anymore. You can activate it and it will add support. Now let's go for run and landing. I enter run type. There is an extra option here, which is the construction. The previous one did not have the structure beneath them, but this one does. So one of them is called underside surface. You see it has two forms, you can see in the picture. When you open this, one of its form is stepped, which is like this, and another one is smooth, which will be flat. You can also control the depth from here. I emphasize the depth, like in the one in support. Alright, the depth is from the tip of this stair until this line. For example, now it's 15 centimeters, I change it to 30 and it will be like this. From the tip to the line. And if it's on the stepped mode, this 20 centimeters will be the thickness. The rest of it is repeated. But let's review it just one more time. In the assembled stairs, we only had tread material and riser material. Now we have monolithic material too. Why? Because it has a structure beneath it. This is the material of its structure. Don't be surprised that the material of these two is not activated. You are going to find out why. Just like you can see, this is only structure. It doesn't have the tread stone or the riser stone. And it's clear because the tread is not activated, neither is the riser. When I activate tread, the tread is added and pushes the structure down. Remember, it pushes the structure down. Look at it once. I activate the thread, you know everything about it, the thickness and all that. And then I activate the riser too. If I enter a number in nosing length, for example 5, because it's slanted, it will be like this. When I activate this slanted, you see how it becomes. You know all of these, I've told you before. Riser, thickness and everything, all of these are repeated. I click on OK. I said we don't need support. But if you like to see what happens, I do it. It's like the previous ones. For example, closed. It's like this. You know, it doesn't look well. But if you need it, you can just add it. I told you how. Now, my final speech about the stairs. We just learned about the technical points of the assembled stairs. We also learned how to change the assembled stairs into the cast-in-place stairs. And we analyzed its technical points too. There is a common subject about both assembled and cast-in-place stairs which I want to talk about now. Alright. If I draw an assembled staircase here, let me draw it. And that's it. I remove the railings. Pay attention very well, it's really important. I also activate the riser that I inactivated so that the stair can look a bit normal. The thing I want to tell you about is the last riser here. You see, both of them have. Though you find it a bit odd to have an extra riser there, this is not actually normal. The truth is that we can have two kinds of stairs here. One of them is that the staircase reaches the level in this way, just like you can see. You see? Here the staircase ends with the riser. You see? This is one kind, and it's what you just saw in the picture. Another kind is this. Alright, let me draw it for you. When we placed this one, we also place a thread, like this. Now, which of these two staircases you think is more organized? And which of them is going to be more useful? That's right, obviously the one on the right. So, the staircase that we just faced in our design must be fixed. It was like this one. It had a riser at the end of it. But what do we want to do now? We want to delete this riser and add one more stair. It will be so much better, but the question is, how should we do that? I mean, how should we inform Revit that we want this kind of this stair? Not this one. Well, this is the explanation. This staircase, its first part is what? Riser. What is the last one? This one is floor. The last one is still riser. This is the stair we said we don't want. The stair that is in our file now. This one starts with riser. But what does it end with? With riser? No. The last one is thread. In Revit we have a kind of setting that is like this. Begin with riser and end with riser. Now you tell me, for the staircase on the left and the staircase on the right, does the staircase on the left begin with riser? Yes, it does. That's right. Now the one on the right, does it begin with riser? Yes, it does. Now the one on the left, does it end with riser? Yes. And now the one on the right, which we want, does it end with riser? No. So it does not end with riser. Therefore, when we want our staircase to be like this, what should we do? It's very simple, we just need to inactivate the end with riser. Now let's go and find out how we can do this. This process is the same in both of them, not different. The first step, inactivating the end with riser. Let's go and see it in the section. So, how should we do this? Select the staircase first, then click on Edit Stair. The stair opens. Then select the last ramp, and then inactivate the end with riser from the properties. And obviously you can see that one riser is deleted. And this is the space I told you not to worry about. This is that. Now we need to go and add one more stair. Please pay attention to this part. We need one stair. You see 20, 19. Now here it has two forms. Either your staircase is sketch or it's automatic. Do you remember from the previous session? If the staircase is automatic, how should we add one more stair? That's right, using the spot, not the arrow. If the staircase is automatic, it's very simple. Just select the last ramp and then drag that spot. Do you remember I told you not to sketch your stairs for nothing because you won't be able to do a lot of things. Now we added one stair very easily. And if you go to the section, you see that it has a thread equal to the level. The design will be very clean and you will have a very nice staircase. So, after inactivating the end with riser and we want to add one stair, if the staircase is automatic, we just need to select it and then drag that spot. Now let's go back and imagine the staircase is sketch. So I convert it. Well, now it no longer has that spot. So how should we add one more stair? That's right, click on its edit and then what? Exactly, copy eraser. Select this and then copy. After that you need to edit the boundary and finally edit the stair path and finish. So you learned, if it's automatic, just drag the spot. If it's sketch, you can copy one riser. We have the same process in the assembled stair. Let's do it here too, as a review. I go to the section, I select it, click on edit and then select the last ramp. You see, it will not be something good, it will not be something perfect. If it were up to me, I would tell you to do this all the time. Always inactivate the end with riser. So go to the last ramp and inactivate the end with riser. And that's it. And here it informs us too. So I go to the plan. And also remember that it doesn't matter that your staircase is assembled or cast in place. If it's automatic, we just drag the spot. If it's sketch, copy the riser. So I drag the spot and then I will have 23 and that's it. In this way you can edit these. Now, here we are lucky about something and we are also unlucky about something. Now, why are we lucky? Well, when you organize all these, for example, the support, the nosing, everything you organized, everything you managed, all of these are saved. Why? Because they happened in edit type. I mean, you don't need to design an assembled staircase and then change it into cast in place. I mean, when you select the stair, you can just change it into monolithic stair and then start designing, and everything you have done before is still here. Oh, I accidentally clicked on that spot. That's why you saw an error on this. I told you we can't edit in the first ramp. Now, why are we unlucky? Instead of every stair you design, after you designed, you can select this and then inactivate the end with riser. But why? Because before you design, there is no ramp so that we can inactivate it. This is really painful, and it's interesting to know that in the old version of Revit, this one was in its type. And I have no idea why they moved it from type to properties. Because if it were in type, it would be saved just like the others, and when you design this staircase, you just didn't need to inactivate the end with riser every time. So remember that every setting remains in the design except the end with riser and adding one stair. You have to add it every time. Just let me tell you something, that the staircases that are really special and weird, there's a strong chance that they don't become monolithic. It's actually related to many things, the form of the riser, the form of the boundaries. It actually depends on many things, but if you see that it does not change into monolithic, don't be surprised. Well, let me draw this. I select it and monolithic. You see, the form does not allow us to change it into monolithic. So, be aware of this point too. Now I want to tell you a point about the connection between the structure of the staircase and the floor. For example, we have this staircase. I select it and I add it in the floors. For example, 2, 3, and 4. And it will be like this, right? Then it's time to design shaft. And about this shaft, there are some points that I will tell you later. Pay attention to what I'm telling you right now, because it's completely related to details, and you must be really careful with this. And finish. I select the shaft and then I say from, for example, level 2 to level 4 or 5, doesn't matter. Now let's go and analyze the section. We have a section here and we want to analyze this together. I click on this and that's how it becomes. Now, in order to be able to understand what I mean better, I will make the zone of this section smaller. You see, I bring it until here, so that when I go to the section, you can see this perfectly, because that's what I want to talk about. The rest of them don't matter. The one at the top is okay. You see, let me move it that way. The one at the top is alright. I want to talk about that one, so I'll make the zone of the section a bit smaller so that you don't see the second ramp anymore. Well, there are two things I want to tell you. The first one is that the triangle in here is empty. What should we do about it? The answer is very simple. Select the stair. Pay attention, you always need this. Select the stair, click on edit, then select it again, and then from the properties you can see an option called extend below riser base. You can, well, let me show you the picture too. You see, that's it. You can type any number you want here. So let's go and type different numbers to see what happens. For example, the first number is 20 centimeters. That is positive. Let's see what happens. And yeah, you see it just ruined our design. So now we find out that the positive numbers are literally useless. But a negative number. And we see that it's useful. See it's 0 one more time. Now 5 centimeters. It comes down 5 centimeters. For example, 20 centimeters. You see here it's still a bit straight. Well, let me tell you something. If you type a very large number, for example 1 meter here, nothing special will happen. You see, it just becomes like this and it makes this part straight. That's it. Therefore, you can use this option to control the structure of your staircase. Now I changed it to 35 and we have the same thing. It's up to you whether you want to bring it until the end or like this. Now, for example, I want it to be until the end. So this is the first point, but the second point is exactly what you're seeing right now. Where did this space come from? When I designed the shaft, look, let me go to level 2. When I designed the shaft, I designed it exactly from the edge of the stair, didn't I? So why did it get like this? Well, that's the point. You mustn't design it from the edge of the stair. While designing the shaft, it's being set based on this. But this stair has a nosing, so you need to come back and start from here. And actually, this is not the main thing to do. The right and the main thing is to stick it exactly to the structure. Even you mustn't consider the thickness of this stone. Just like I told you in the previous parts, this stone must be on the thread. But how? Well, we go to edit type, run type. Now you need to switch the places of these two. Riser to thread, extend thread on the riser. Just like this. Alright? And now check this part. You see how it becomes? Let me undo so that you can see it one more time. You see? You see how it was before? Let me do this one more time. Check this. That's how it becomes. This is wrong. It must be like this. And now that shaft must be moved to the left a bit to stick to the structure. And it will be as the size of the nosing of the stair and the thickness of that stone. But how? At first select the stair. We check it one more time. We go to the run. The nosing 3 centimeters. The riser thickness 12.5. Which becomes 42.5. I select the shaft and then edit. And then I select this one and move. And I move it 42.5. And now see the result.